Welcome and hello. This is a video exercise using the FHWA hydraulic toolbox, and I'm titling this one Heat Runoff, Heat Flow, and Shallow Flow. So sheet flow and shallow flow are two different ways to calculate the time of concentration, which will ultimately allow us to determine the peak runoff using the rational method. Right, so we're going to be using the rational method calculator in the hydraulic toolbox. What you see on the screen is the problem statement. We are looking for the runoff in units of cubic meters per second. So this is going to be using the metric unit system. And then we're also provided some other data that you see on the screen here, such as the sheet flow data, shallow flow data, as well as some watershed parameters, such as the area, and then the storm data and the land use type. Okay, so let's go ahead and get started. I'm going to minimize the problem statement. And what we have right here is our hydraulic toolbox. I'm going to go right click, new rational method calculator, or rational method analysis. You can right click and then rename it to something you want. You can just call it the name of a watershed or a basin or sub-basin. I'm going to double click to open up the calculator now. And then what we need to do is provide the runoff coefficient, the area, and the rainfall intensity. So the product of those three terms times a conversion factor will give us our peak flow rate, Q, in units of CMS. So I already have the unit system set to metric, but if you don't, you can change it from this drop down or from the units menu. Also, while we're talking about the user interface, the user's manual is available by going up to the help menu. It's this first option, hydraulic toolbox user's manual. If you click on that, you'll get a PDF. Here is the PDF file. So this is the user's manual, and we're going to go ahead and reference that as we have in previous lessons and exercises. And then the HEC22 document is also one that we're going to be referencing in this video. It's the hydraulic engineering circular number 22, specifically page 26, I believe. Yes, this is where we're going to get our runoff coefficient values based on land use. And I'll leave a link in the description where you can download that document. Okay, so anyway, back to our calculator for watershed or our basin. I'm going to type in the runoff coefficient. Now, I don't have that number yet, but what I've been provided in the problem statement is that the area is 28 hectares, and then the land use is residential single family. So if we go to that HEC 22 document, I'm on table 4.1, page 26. This is that table for the land use versus runoff coefficient. We see the different land use categories in the far left column, business, residential, industrial, and so on. And then there's a subcategory here in the second column. And then finally, the runoff coefficient. So we have residential and single family areas, which means our range is between 0.3 and 0.5. So we could go with a min and a max, or we could just say it is somewhere in the middle, like 0.4 is, I guess you could call it the average. So let's go ahead and do that. If we want one single flow rate, then let's just select one single runoff coefficient. Okay, so I'm going to go with 0.4. So let's minimize that. We also know the area is 28 hectares, so we can enter all that information at the same time here. Runoff coefficient 0.4, and 28 hectares. Okay, next we need to provide the rainfall intensity. So to do that, I'm going to click on compute because it's going to be a function of the design storm and the time of concentration. So right now we don't have any data here for the IDF curve, which will return the intensity, which is what we're looking for, based on the time of concentration. But we were provided that information in the problem statement for the 25-year return period storm for different intensities ranging from 5 minutes up to 60 minutes. So let me bring that up once again. Here's the table for duration versus intensity. The units are already in millimeters per hour, so there's no need for a conversion there. Here's the toolbox. Okay, let me move this over. And I'm just going to copy the numbers over. So 132, 104, 86, 58, and 38. So when I click OK, we have this 25-year data that's ready to go. And then we have the plot and the best fit curve, the IDF equation for intensity as a function of the time of concentration. T sub C here is in units of minutes. So this curve right here is this curve. So we're ready to go. All we need to do now is calculate the time of concentration. If we knew the time of concentration, we could just type it in here, click on compute intensity, and be done. But we don't know what it is yet. So we're going to compute it based on the data provided in the problem statement. So click on this radio button for compute T sub C, then click on define parameters. And what we have been provided is the sheet flow data and the shallow flow data. So I'm going to move this over to the side and just type it in at the same time. Sheet flow, shallow concentrated flow, and there's also this channel flow here. But we weren't provided any channel flow data, so I'm just going to uncheck that enabled checkbox to disable it. And then next, I'm going to start adding in the data that I do have for sheet flow. So the top elevation is 380. I'll click on tab to advance to the next field. Bottom elevation, 370. These are units of meters. Okay, the length, 200 meters. And sometimes you have to hit tab a few times. Manning's roughness is 0.06. And then finally, the last required input here for sheet flow is the 2-year, 24-hour precipitation depth. Now, I was provided a IDF curve as well, which is what we're going to reference right here. So the horizontal axis is the storm duration, and the rainfall intensity is the vertical axis. It happens to be in inches per hour, but that's not a problem. We can convert. So for 24 hours, that's this pink vertical line. And then the 2-year storm is this orange or yellow line. And where they connect or converge right here represents our specific 2-year, 24-hour storm event. So if we trace over to the intensity axis, the vertical axis, that's 0.15 inches per hour. I know it's kind of hard to read, but that would convert to 3.81 millimeters per hour. I was looking for the 24-hour depth, not intensity. So we just have to multiply 3.81 by the 24 hours in the 24-hour day. And that comes out to 91.44 millimeters. So that is what I'm going to type in right here and tab off. Okay, so it's giving me the slope of 5% and the time of concentration is 13.85 minutes. All right, so that is the time of concentration contribution from the sheet flow. We then need to add in the shallow concentrated flow time of concentration to get our total time of concentration. The top elevation is 370, that's correct, which is actually a disabled field because it's set to whatever the bottom elevation is for the sheet flow. So that's a nice little convenience feature. The bottom elevation is 365. This is given data. And then the length, again, is 200 meters, same as before. And then finally, this K value right here, this was given as 0.55. There's also a reference here for this K value, see HDS2, table 2.2, which is also copied into the user's manual. So let me get that up. I have page 34 and 35 written in my notes. Okay. So if you're curious about where those calculations are coming from for time of concentration, here is the overland/sheet flow. Here's a screenshot from the user's manual with some example numbers. Here's the actual equation right here, T sub C. And then further down on the same page, we have the time of concentration calculation for the shallow concentrated flow with some example numbers and a screenshot, and then an equation here for the velocity, which you can use to calculate the time of concentration. Okay. And then further down, it looks like it's on the top of the next page, page 35. Here are some example values for that K parameter based on the different land cover/flow regimes. So we're using 0.55. It looks like it's right here in the middle of the shallow concentrated flow section. Okay, so I'm going to minimize that. And then what we have from our shallow concentrated flow is a time of concentration of 3.81 minutes. So we're going to add that time to our 13.56 minutes to get a total time of concentration of 17.66 minutes. Okay, so that is how to use the time of concentration calculator. If we click OK, that 17.66 minutes, it's carried over here to right here, 17.7 minutes. If we plug that into our equation, it should give us our intensity, which is 79.132 millimeters per hour. Now we're entirely done with this dialog box, whose purpose was to return the rainfall intensity. So this 79.1 millimeters per hour should be copied over right here. And it is. We have our time of concentration, recurrence interval, and our final answer to the problem, which is the flow rate of 2.5 cubic meters per second. So that is it for this exercise. What we did was solve for the peak flow rate, which is the runoff from our 28 hectare watershed using these parameters and the rational method calculator in the hydraulic toolbox.